Problem 24, Chapter 3. A certain centrifuge produces a centrifugal acceleration of magnitude exactly 1000 g at a point 10 centimeters from the axis of rotation. Find the number of revolutions per second. Alright, so let's draw a picture first. This is a uniform circular motion. So an object is going in a circle. There is a radius r, about a center of rotation O. And we know that despite the fact that the speed is constant, the velocity is not, and therefore that there is acceleration. And that acceleration is given by the velocity squared divided by the radius. That's a sub c, which we are given as 1000 times g. Now I'm going to rewrite this equation. V is equal to omega times r. So I put that in here. The denominator becomes equal to omega squared r squared over r, which in other words is equal to r omega squared, and that's equal to 1000 g. And so the way I'm going to solve this problem is I'm going to solve for omega, which gives me rads per second, and then I'm going to convert rads per second to revolutions per second. So two-step process. Let's solve for omega first. So from this latter equation, r omega squared is equal to 1000 g. I can conclude that omega is 1000 g divided by r square root. So in other words, that's 1000 times 9.8 meters per second over 10 centimeters. Well, 10 centimeters is a tenth of a meter, and I want the square root of that. Check your dimensions. Meters cancel out. I get 1 over second squared. Square root of 1 over second squared is seconds. And so the dimensions for this are 1 over seconds. Radians are understood. So if we, radian itself is dimensionless. If we do the calculation here, take the square root of what's under the square root sign, we get 313.1 rads per second. Now I want to convert that to revolutions per second. That's what we're asked for. And the units are similar. They're both telling us how fast this object is rotating. So I'm going to take this and I'm going to do a unit conversion. And I'm going to do that based on the fact that 1 revolution is equal to 2 pi rads. So you can see the rads are going to cancel out, and I'm going to get rads per second when I do that. So when that division is done, I get 49.8 revs per second. Revs per second is a very common unit of angular speed. You also hear revolutions per minute, aka RPM, and in order to do RPM for this, if we wanted to, what we would do is we would go 49.8 revolutions per second, and then I would multiply by the conversion factor 1 minute 60 seconds. And so in RPM, RPMs, this is roughly 50, so 50 times 60 would be what? 3,000 RPM, roughly equal to 3,000 RPM. Or 3,000 RPM.